Welcome to Teachin Learning. Today's topic of discussion is arithmetic progression, and in short, it is also called an AP. So this is the first part of today's lesson of arithmetic progression. So let's start. Can you fill the three blank spaces here? If your answer is a star, then triangle, then star, then you are perfectly right. Can you fill three blank spaces here? I think you are ready with your answer. If your answer is 1 1 1, then again you are perfectly right. Now have a careful watch. uh, Carefully see all the numbers in the list. uh, Can you fill these three blank spaces here? If your answer is 12, 30, 14, then again you are perfectly right. Very good. Can you fill these three spaces here? Have a look. Carefully look at these numbers and try to fill these spaces. If you can fill these spaces with 19, 21, 23, again you are perfectly right. Can you fill these three spaces here? Carefully watch all these numbers and try to fill these blank spaces. If your answer is 22, 24, 26, then again you are perfectly right. You are getting smarter. So you are perfectly right. Can you fill these three spaces here? Have a careful watch on these numbers. Carefully watch these numbers. Look at these numbers carefully and try to fill these spaces. Now I think you have got the answer. If your answer is 32, 64, 128, then again you are perfectly right. Now have a careful look at all these numbers. 1 by 1, 1 by 3, 1 by 5, 1 by 7, 1 by 9, and so on, so on. Now, after having a careful look at these numbers, can you fill these spaces? Now I think you can fill these spaces. If your answer is 1 by 19, 1 by 21, 1 by 23, then again you are perfectly right. Can you fill these blank spaces here? If your answer is 22, 24, 26, then again you are perfectly right. So now have a look at these two list of numbers. Each term or each member of these lists are called a term. So 2 is first term of this list, 4 is second term, third is 6 is third term, 8 is fourth term, and so on. So each member is Each member of such type of list is called a term. So each member is referred as term. Now we are ready to understand what a progression is. So mm, have a careful look at these numbers. Carefully look these numbers 2, 4, 6, 8, 10, 12, 14, 16 is a progression. When we can, the list of numbers is a progression. Now you can see that 4 can be obtained by adding 2 to its previous number. 6 can be obtained by again adding 2 to its previous number 4. 8 can be obtained by adding 2 to say previous number 6, and so on. So if when you are acquainted about this type of phenomena, you are now able to feel uh, many numbers after 16. So you will get 18 in this series. You will get 18, 20, 22, 24, and so on. So what is a progression? Pro you find that two numbers are related. Any two consecutive numbers of a list is related by a rule. So when a list is following some rule in which each two consecutive number is related with a rule, then this list of number is called a progression. So what a progression is? A list of numbers in which each term is related to its preceding term with a rule is called progression. I think now you have got the concept of progression. There is two types of progression. First one is arithmetic progression, second is geometric progression, third is harmonic progression. So let's try to understand all these progressions one by one. First one is arithmetic progression. When you see this list, you will find that the two consecutive numbers is related in such a way that the next number can be obtained by adding a fixed number to its preceding term or previous term. So uh, 12 can be you can get 12 by adding 2 to 10. You can get 14 by adding 2 to 12. You can get 16 by adding 2 to 14, and so on. If you can get its next term. If so, to get the next term, you will add 2 to 16. It will be 18. To find the next term of 18, you will add 2 to 18. It will be 20, and so on. You will find 22, 24, 26, 28, 30, and so on. So, an arithmetic progression is a list of numbers in which each term is related with the preceding term in such a way so that the next term can be easily obtained by adding a fixed number to the preceding term except the first term. Second is geometric progression. Watch these numbers. You can get the next term by multiplying to its previous one. So 4, you can get 8 by multiplying 2 to 4. 4. You can get 16 by multiplying 2 to 8. You can get 32 by multiplying 2 to 16, and so on. You can get more terms here. So how can you define geometric progression? A geometric progression is a list of numbers in which each term is related with the preceding term in such a way so that the next term can be easily obtained by multiplying a fixed number to the preceding term except the first term. So when you multiply a fixed number to its preceding term, you will get the next term. So 2, when you multiply 2 into 2, you will get 4, 4 into 2, 8, 16, 16 into 2, 32, 32 into 2, 64, 64 into 2, 128. So uh, this series is called geometric progression. This progression is called geometric progression. Now, third one is harmonic progression. A harmonic progression is a list of numbers in which each term is the reciprocal of the terms of an arithmetic progression. So to understand this, let's have an arithmetic progression which we have discussed earlier. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23. So what you will find that next term, the difference between the two term is two consecutive term is fixed. 23 minus 21 to 19 minus 17 to 17 minus 15 to. So clearly this is an example of arithmetic progression. So when a harmonic progression is a list of numbers in which each term is the reciprocal of the terms of an arithmetic progression. So when you get the reciprocal of these terms of an arithmetic progression, you will get the harmonic progression. So it reciprocal of 1 is 1 by 3, reciprocal of 3 is 1 by 3, reciprocal of 5 is 1 by 5, reciprocal of 7 is 1 by 7. So all these forms forms a harmonic progression. So depending on the number of terms, we can divide progression in two types. First one is finite progression. A list having finite number of terms is called finite progression. Or you can say a list having fixed number of terms is called finite progression. As you can see in this example, 1, 2, 3, 4, 5, 6, 7, 8. This is a progression, but the number of terms is fixed here, and it has 8 terms, so it is a finite progression. Second one is infinite progression. Infinite progression is a progression in which the number of terms is infinite. You can't say that you can't say anything about this progression that the number of terms is 4, 8, 10 and so on. So let's understand infinite progression. A list having infinite number of terms is called infinite. So it will end never. This progression will end never. So it has infinite number of terms. So it is called infinite term. Now, uh, finite arithmetic progression. What is finite arithmetic progression? An arithmetic progression with finite number of terms is called finite arithmetic progression. It's called finite arithmetic progression. For example, 2, 4, 6, 8, 10, 12, 14, 16. These terms forms an arithmetic progression, but the number of terms is finite. And how many number of terms this list of number has? 1, 2, 3, 4, 5, 6, 7, 8. So this list of number has 8 terms and is fixed. So it is called finite arithmetic progression. Now, infinite arithmetic progression. An arithmetic progression with infinite number of terms is called infinite progression. Let's see this example: 2, 4, 6, 8, 10, 12, 14, 16, and dot dot means it will end never. It will go up to infinite. So the number of terms is not fixed, therefore it is called infinite arithmetic progression. This is arithmetic progression, but its number of terms is not fixed, so it is infinite arithmetic progression. Now let's come to the topic arithmetic progression. Let us revise what arithmetic progression we have defined earlier. Arithmetic progression. An arithmetic progression is a list of numbers in which each term is related with the preceding term in such a way so that the next term can be easily obtained by adding a fixed number to the preceding term except the first term. So have a careful look at this list of numbers. You will see that each two consecutive term is related in such a way that the difference of any two consecutive terms is static. 4 minus 2 to 6 minus 4 to 8 minus 6 to 10 minus 8 to 12 minus 10 to 14 minus 12 to 16 minus 14 2. So what you got? You get that the difference between any two consecutive term is static. So when the difference between any two consecutive term is static, it is an arithmetic progression. So basically the first term in this list of number or in this progression, the very first term is called first term, and the fixed number that uh, is added to get the next term is called common difference. So what is common difference here? When you subtract 8 when you subtract 8 minus 6, you will get to 10 minus 8 to 12 minus 2. So you can say that the difference between two continuous terms is called common difference. So the entire AP is dependent on two attributes. Basically, the first one is first term and the second one is common difference. If you get the first term and common difference of an AP, you can find many number of terms of a given AP. So basically you have two terms or two attributes related to the arithmetic progression. Attributes of an AP, as we have told, an AP is fully dependent on the first term and the common difference. So when you get the first term and common difference of an AP, you can find a many number of terms of an AP. And try to remember what is common difference. The difference between any two consecutive terms of an AP is called the common difference. Usually, the first term of an AP is denoted by A and common difference of an AP is denoted by D. Let's take an example to understand A and D, that is first term and common difference. So let's take an example. 3, 5, 7, 9, 11, 13, 15, 17, 19, 21 are the list of numbers, and it is an arithmetic progression. When you have a careful look at these numbers, you can detect that these are members of an arithmetic progression. So here the first term is 3 and common difference is for common difference you can find the difference of between any two consecutive terms. So you can find the difference as 5 minus 3. or 21 minus 19, or 17 minus 15, and the difference will remain intact, and it is here 2. So a is 3, first term is 3, and d under d you got as next term minus preceding term. So preceding term is subtracted with the from the last term. Students make mistakes while computing the while calculating the common difference. They usually do mistakes by subtracting the preceding term minus next term. So it is reverse of this. So please remember, when you compute t, you calculate, you can get it by subtracting preceding term from the next term. So here in this example, subtract 7, you can do 17 minus 15 is equal to 2. You can't do 15 minus 17. Please remember this point. Now arithmetic progression. If the terms of an AP is denoted by T1, T2, T3 and Tn, whose terms is A, whose first term is A, and the common difference is denoted by D, then the first term will be A, second term you can get by adding its first term D, T3 you will get T3 as T2 plus T, T4, fourth term will be T3 plus T, T5, fifth term will be you can get fifth term by adding the common difference to its preceding term, that is T4. In this way you can find all these terms. Now when you can compute T2 as we can put here T1 is equal to A, you will get T2 as A plus T. When you compute T3, you can get it by adding D to G2. So when you add D to T2, and T2 is what? A plus D. When you replace T2 by A plus D, you will get it as A plus 2D. You can add. Now in this way you can get T4 as replacing T3 by A plus 2D, you will get A plus 3D. In this way you will find that T5 is A plus 4D. And so can you tell by going this way, you tell its nth term? When you replace these numbers 1, 2, 3, 4, 5 by a variable n, can you find nth term? You can easily find this term. What will be the nth term? You can find nth term as when you have careful watch, when you see carefully at all these terms. T3 is A plus 2D, T4 is A plus 3D, T5 is A plus 4D. So what is happening? When you have 5 here, you have 4 here. When you have 4 here, you have 3 here. When you have 3, you have 2 here. So here is a number 1 less than this number, and you find that these are following a pattern. So when here is n, then in place of 4, here will be 1 less than n. So 1 less than n is n minus 1. So you will get Tn as you will get Tn as A plus n minus 1 into D, where n is a natural number like 1, 2, 3, 4, 5, 6, and Tn is called a general term of an AP. Tn is called a general term of an AP, or arithmetic progression. If the general term of AP is denoted by Tn, the Tn is equal to A plus n minus 1 into D, where n is natural number like 1, 2, 3, 4, 5, 6, and Tn is called the general term of an AP. So now it has become an important formula, and we will try to memorize this formula for to solve exercises on based on this formula. So the general term of an AP is denoted by Tn, and its value is A plus n minus 1 into D, where A is the first term and where A is the first term and D is the common difference. So if you have understand the topic, please like the video and subscribe to the channel. Also press the notification bell button so that you can get notified when we upload a new video. Thanks for watching. Thank you. Please subscribe. Don't forget to subscribe.